Hi and welcome back. So in this problem, we're going to be solving a problem called house robber. So let's get started and see what the problem is. So the problem statement is as follows. You're a professional robber and you're planning to rob some houses along a street, and each house has a certain amount of money stashed in it. And the only constraint stopping you from robbing all of these houses is that you cannot steal two houses which are beside each other. So if you steal any two adjacent houses, then the police is immediately notified and you go to prison. So the question asks you, how do you steal the most houses without going to prison and at the same time making the most amount of money, right? So here's an optimization problem. So we're given a list of non-negative integers representing the amount of money in each house. And we want to determine the maximum amount of money that you can rob tonight without alerting the police, okay? So you can't steal two houses which are adjacent. So let's take an example for this. Let's say we have an array of 1, 2, 3, 4, 5. So one possible idea is we can rob house 2 and 4, or we can rob house 1, 3, and 5, or we can rob house 1 and 3, or we can even rob house 2 and 4. So, and so on. And the optimum here is when we steal house 1, 3, and 5, because we end up with 1 plus 3 plus 5, which is $9. And we don't alert the police because we didn't steal two houses beside each other. So if we would have stolen, for example, 1, 2, and 5, then we would alert the police and we would go to jail. So it's not a valid one. Okay. So let's think first of a recursive solution, right? Let's say that I want to steal houses from 1 to I. So I'll define Ri as the maximum money that I can steal from house 1 to house I, okay? Now, there's two cases here, right? There's only two cases here. You either steal house I or you don't, right? What happens if you steal house I? Then you can't steal house I minus 1, right? Because if you steal house I minus 1, then that means that the police is alerted. But you can steal from houses 1 all the way to I minus 2, right? These are okay to steal from. So if you steal from house I, then we can say that the maximum money that you can steal from house 1 to I is nums I, right? So nums I here is the number or the cost of that you can steal from this house plus the maximum of houses I minus 2, I minus 3, all the way to 1. So the maximum money that you can steal from houses 1 to I minus 2. Similarly, if you don't steal from house I, then the maximum money that you can steal is just Ri minus 1, because you only steal from the previous I minus 1 houses. Now notice here that we used the maximum of Ri minus 2, Ri minus 3, and so on. Why is that? Well, the reason is we might not want to steal from house I minus 2, but steal from house I minus 3. So it's not necessarily that we're stealing only from these houses, right? We might steal or from house 1, 2, all the way to I minus 3. Okay, so that's why we have this maximum here. Okay, so if we don't steal from house I, then that means that the maximum money that we can steal is Ri minus 1, right? The maximum money you can steal from house 1 to house I minus 1. Okay, so our overall money, the maximum money that we can steal, is the maximum of these two cases, right? It's either you steal house I or you don't steal it. So I'll take the maximum of both of them. So either Ri minus 1, meaning you don't steal from house I minus 1, or this one here, which means you steal from house, steal this house and steal from the steal from the previous I minus 2 houses. Okay, so what is the base case here? The base case here is R1 is equal to nums 1. So when there's only one house, you can only steal the first house. But when there's two houses, then we can steal the maximum of both of them, right? If I have, for example, houses like 4 and 5, then I should probably steal the house 5 because I earned more money. But I can't steal both of them because I would go to jail. Okay, so here's a possible recursive solution based on the recurrences that we derived in the previous slide. So we're first including iostream and vector and using namespace standard. And then we're defining a function, a recursive function called rob, that takes an I. So this corresponds to R of I, right? So we're taking in a recursive function, we're writing a recursive function that takes I and the vector of numbers that you can steal. And then the base cases is if I is 1, then simply return num 0. And it's 0 here because the indexing in programming in C++ starts from 0, in most languages actually. So we take num 0, the first house. If I is 2, on the other hand, then we simply return the maximum of num 0 and nums 1, the first house and the second house. Then, if this is not the case, then we want to return the maximum value of either R I minus 1, which is here, or the maximum of rob j nums plus nums I minus 1, where j ranges from I minus 2 all the way to 1, right? Because we said our nums I minus 1 plus R I minus 2, or the maximum of R I minus 2, or R I minus 3, and so on. So this takes the maximum of all of these values. Finally, we return the maximum value between these two values, and that's our sum. So to test this function, I tried here to do 2 unit tests here. So one possible configuration of the houses is 1, 2, 3, 4, 5, and the optimum here would be, again, 9. We'd steal 5 and 3 and 1. So that's total of 5 plus 3 plus 1, which is 9. Another one is this one here, and here the optimum is we steal 6, 4, and 2, which in this case ends up being 12. So this program should output 9 and then 12. Okay. Now, this solution is good for small values of n, but we end up doing a lot of recursive calls, and this solution ends up being an exponential solution. Now, we won't go into too much details of why this is true, right? But for now, you can know that this solution is actually quite bad. It's exponential. And there's actually a very good mathematical derivation of why it's exponential, but I think it's a bit more advanced for this course, so I won't put it. So yeah, so what do? In this case, we have a recurrence relation, right? So the first idea that should pop up to your mind is, okay, can I write this as a dynamic program? So the solution to our problem is dynamic programming. Again, we're going to write R0 to n be an empty array of size n plus 1. And then I'm going to set S0 as num0 and S1. So sorry, here, so this should be S here. So S0 is num0 and S1 is the maximum of these two. Now I'm going to go for I equal 2 to n. So I'm going to loop over all the values. I want to fill out my dynamic programming table. And then I'm going to say first Ri is Ri minus 1. Okay, so I first set up the first value. And then I go for j equals 0 to I minus 2. Ri is the maximum of the current value. So its current value. And nums I plus Rj. So this is exactly the same from the recurrence in the previous recursive solution. And then once I'm done with this loop, then I simply return Rn. So here, Rn will have the value of my recurrence that the previous solution had. But let's analyze the running time of this solution. This loop here is O of n. Similarly, this loop over here, I can at most be n, right? So this loop might take O of n time. So the overall running time of this algorithm should be O of n squared, which is much better than an exponential solution. So here's an example of the dynamic programming solution that we discussed in the previous slide. So we initialize the value of R0 as num0 if there's only one house, and here we're using 0 and 1 because, again, the indexing in most programming languages start from 0. So we do R0 is equal to num0, the first house, and R1 as the maximum of if we have two houses. Okay, so this is a bit confusing, but if we have two houses, then we take the maximum of the first house and the second house. Then we loop over all the values from I equal 2 to n. We're filling the dynamic programming table R, and then we say, okay, first of all, the expression has the maximum of Ri minus 1, so I initialize it to Ri minus 1, and then I go for nj from I minus 2 to j bigger than or equal to 0, minus minus j, and then I set the maximum is the current maximum, so it's Ri, the value of Ri is the current maximum, or Rj, so the value of j, so R, for example, this would be R3 plus nums I, or R2 plus nums I, or R1 plus nums I, right? So this expression here would take the maximum of all of these and Ri minus 1. So in the end, after we're here, so after we reach this step, Ri is the correct value of the recurrence. Hence, after we terminate this loop, the value of R at n minus 1 is actually the value that we're supposed to rob. So again, if you run this solution, you should get exactly the same answer, 5 plus 3 plus 1, which is 9. So in this video, we saw how we started with a simple idea of a recurrence, which then led to a recursive solution. And from that recurrence, it's very easy using just a dynamic programming table to take the solution and change it to a dynamic programming from the recurrence, so you can take from the recurrence idea, you can change it into a dynamic programming table and use that to change the complexity of the whole problem from an exponential to a O(n) squared solution. So a very good improvement. So hopefully this video was clear. And if you have any questions, let me know in the Q&A section. Until the next video, happy coding.